Let's take a look at a question that deals with the combined gas law. So the question reads, in 1783, Jacques Charles launched his first balloon filled with hydrogen gas, which he chose because it was lighter than air. The balloon had a volume of 31,000 liters, so that's 2 sig figs, at a pressure of 755 millimeters mercury and a temperature of 22 degrees Celsius. When the balloon reached an altitude of 1,000 meters, so it was up a kilometer in the air, the pressure was only 658 millimeters mercury, and the temperature had dropped to -8. What was the volume in liters of the balloon at these conditions if the amount of hydrogen remains the same? So where I would start is writing down everything that I know. So I know that the initial volume of this balloon is 31,000 liters. Again, that's only 2 sig figs because there's no decimal in there. The initial pressure is 755 millimeters of mercury. The initial temperature is 22 degrees Celsius. If I add 273 to that, I can convert that to Kelvin, so it's 295 Kelvin. Then my volume is what I'm trying to determine, is what volume was attained at this height, at this pressure and this temperature. And I know that that pressure was 658 millimeters of mercury, and the temperature was, temperature 2 was equal to -8 degrees Celsius. That's pretty chilly. So if I convert that to Kelvin, I get 265, again by just adding 273. So I have volume, pressure, and temperature, and it tells you that the amount of hydrogen remains the same. So that didn't change. So that means we don't have to worry about N. We can leave out the number of moles. So hopefully you can identify this problem as one where we have to use the combined gas law. So the combined gas law is P1 times V1 over T1 is equal to P2 times V2 over T2. And in this case, we're solving for V2. So if I circle V2, so V2 is going to be equal to, it's going to be P1 times V1 multiplied by T2. So P1 times V1 multiplied by T2. And then I divide that by T1 times P2. So hopefully you can solve that in your head. If you can't, that's okay. You can just cross multiply and cancel out the variables. So I'm going to work down here. So I say my V2, so my original pressure is 755 millimeters of mercury. I know it might seem tedious to write out all these units, but you don't want to leave them out and make a mistake. You get 31,000 liters. Again, that only has 2 sig figs, multiplied by 265 Kelvin, which is the second temperature. So we're going to make a straight line. Divided by 295 Kelvin, multiplied by my second pressure, which is the 658 millimeters of mercury. There we go. So everything's written in. Let me go back to my blue pen here. You can see that millimeters of mercury are going to cancel out and Kelvin cancel out, and I'm left with liters in the numerator. So when I punch all that into my calculator, I end up with a number that's 31,900 something. But again, it only has to have, or it can only have, 2 sig figs, so I'll report it as 32,000 liters. So the volume of the balloon went up by 1,000 liters. So again, this is a question that uses the combined gas law, and it's a good idea to commit the combined gas law to memory whenever you're doing a chapter that deals with gases. So hopefully you find this, this question and solution helpful.